Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera again. Okay, so this should be our second meeting, and today meeting we'd like to focus on the title stated on the white paper, which is revision on vector. I already upload the handout for you to go through, which is known as handout number 1. So I'm going to place it here. So this should be already available in the e-learning website. So this is called handout number 1. Okay, I'm hoping that you have already go through it yourself, and might be some of you have gone through the link video I already uploaded in the e-learning and go through the lectures given by Professor Walter Levine, and maybe some of you already go through yourself based on various information that you can gather. So the reason why we are doing this exercise is just to familiarize ourselves to how we would like to present vector in this particular course, because we already should know by now vector can be represented in many approach. So in order to avoid confusions, we like to familiarize ourselves how vector we're going to present in this particular course. Okay, so that's the main objective. We want to show how we present vector in this course in order to avoid confusions. So another thing I'd like to highlight here, in this particular exercise, we're going to focus on this particular coordinate system, which is Cartesian coordinate system. Okay, we are not talking about other coordinate system, which inshallah I'm going to discuss in my future video, which is related to the orthogonal coordinate system. So coming back to this handout, we're going to focus on one coordinate system known as Cartesian coordinate system. So that's what we're going to do. Okay. Okay, so let's go through the first question here. Okay, fundamental of scalars and vector. This just to differentiate a symbol in physics, in engineering, in many applications can be presented either in scalar and vectors. Okay, so when we talk about scalar, it only contains one information, which is magnitude. Whereby when we talk about vector, it having two meaning, which are the first one magnitude and the second one directions. Okay, that should be clearly well understood already. Very basic here. Okay, now let's represent that meaning, magnitude and direction, in terms of proper representation. And we're going to go back to the coordinate system here, Cartesian. Okay, let's do this exercise. Is vector B. Okay, as you can see now, a symbol, letter having arrow on top, so that's how we represent a vector. It's expressed in the form of Cartesian format here. The x component having a unit vector x, the y component of magnitude having unit vector direction y, and the z component of magnitude having direction z. Okay, how are we going to represent the vector, the magnitude of the vector? So that's what the question asks. How are we going to represent that? Okay, so that's what should be what we're going to do here. Okay, so given here, the vector B is equal to B subscript x and then unit vector ax plus B subscript y unit vector ay plus B subscript z unit vector az. Okay, so this represent the magnitude, this represent direction, we call it unit vector. The special characteristic of unit vector, so this vector having both information, magnitude and direction, but the magnitude of this vector always equal to 1. Okay, so again, we tie this equation with respect to Cartesian coordinate. So we are saying vector must have two information before which magnitude and directions. Okay. So therefore, magnitude B should be presented in terms of magnitude symbol B like this, and the direction always symbol A hat B. Okay, that's how we represent directions. Okay, so magnitude of B here actually just the square root of the x component square plus y component square plus z component square. That should be the magnitude. Okay, and the directions, so we define it to be unit vector now, should be AB should be equal to the vector B, and then we're going to divide with the magnitude of B. So that's how we define the direction, or to be more precise here, unit vector. Okay, so that should be how we represent vector in Cartesian in electromagnetic subject. So what we have done now, we have completed this particular how we represent the magnitude and how we represent the direction, or in other words, the unit vector of that particular vector. So that's define directions. Okay, so that's done. So let's go to the second question here. Which is overview on the dot product, or sometimes we call it to be scalar product. So what we have here, 3 points in space. So these points create a triangle, and then each point presented by 3 variables. So A, in this case, 4 minus 1, 7. B minus 1, 5 minus 4. And C minus 5, 2, 1. And all the representing the x component, y component, z. Because why? We are linking this problem to the Cartesian coordinate. Okay, so let's give this as a try now. Okay, so number 2. So what should be the vector of AB? Okay, vector of, so this we define to be the vector joining point A to point B. Okay, A, let's make it to be given by this notation. 4 minus 1, 7. And B, let's make it to be located here, which is minus 1, 5, minus 4. So what been asked for us to define here, what is the vector joining point A to point B? So this is the vector, what we call it to be vector R from A to B. In other words, we call it to be position vector. How we define that in terms of mathematics, and I'm sure most of you can already conclude the solution here. So let's compare here. So what we're going to have now for vector RAB, so R from A to B, the sequence is very important. Okay, from A to B, meaning that what I have now, the magnitude of B, which is -1, I'm going to -4, and then I'm going to put it to be X component, and I'm going to add with the Y term now, should be 5, which is the B variable for Y variable of B point, minus -1, and that should be represented by the Y component, and plus the last term should be the Z -4 minus 7Z component. So we can have it to be equal to -5. Let's make it another. We can write the unit vector to be simply X, the hat, and then should be plus 6Y hat, and then minus 11. So that should be the solution for the vector or position vector from A to B. Okay, that's done. Okay, so let's go for the second one. For the second part of the question here is asking us what's the angle between BAC at the vertex A. So meaning that we want to find at the point of the location A, what should be the angle of this triangle. Okay, let's draw it now. Okay, so we have A, B, so I'm going to make it repeating, redraw the diagram now. I'm going to have A here, let's say. So this should be A, so this should be our B, and let's make here the new point here as our C. So this should be the triangle now. So what we want to define now, the angle here. So this angle theta. So that's what we want to determine, that angle theta. So as the title of this particular part of the question is regarding dot product, logically we're going to adopt dot product as our approach. Dot product as our method to solve this problem. So what's dot product? So let's say now dot product, what we can see now, there's two vectors now. So one vector we have defined earlier, so that should be the first interested vector we want to consider. We call it to be RAB, and at the point A we can see another vector appear, which is this second vector. We call it to be RAC. Okay, so logically what we're going to use now, we're going to define RAB, which is the vector RAB. If I dot with the vector RAC, because we want to find the angle at A, so by definition, that should be defined as the magnitude of vector RAB. Remember, we already defined what magnitude before, and the magnitude vector of RAC, and then we have to multiply the angle cos theta. Okay, so that should be the proper equation we use. So we can solve the left hand side, we need to find the magnitude, and from there we'll be able to define or to find the angle. Okay, that's how we actually determine the angle theta. Okay, by using this equation, because we are actually doing revision on dot product at this particular exercise. Okay, so I don't have to solve this, I'm just giving you idea here. I believe that most of you are able to do it. So what the reason why I want to solve this particular problem here, I want to show you how we actually solve the third question, which is quite an interesting question to be solved, because it's something quite new, and then maybe we use a lot of this idea in this particular course, the projection vector. Okay, so that's what we're going to do now. Okay, what the question asks us to do now, find the vector projection of RAB on RAC. Okay, RAB on RAC. Okay, let's draw that again. So we have A here, so that should be our point A. B we already defined up here. Okay, this is our point B. So let's say C, we define it to be here, C. So we have two vectors already. We defined first the vector RAB. So that should be the vector RAB we calculate and we already defined it earlier. And RAC is the new vector that we already determined in the second part of the question, RAC. And from this particular exercise, we already able to define the theta. So what is the projection vector of RAB on RAC? So that's what we're going to try to investigate. So when we talk about projection vector RAB on RAC, we can simply say here what is the component of RAB appear to be on the direction of RAC. So what you have to do, we need to project the vector RAB to be coinciding with the vector RAC. How we do it? We split this into two components. One will be parallel to the vector of RAC. Another one is normal to the vector RAC. So this particular vector we call it to be the vector projections of RAB on RAC. So that's what we call it, the projection vector of RAB on RAC. How much of the vector of RAB appear to be in the direction of vector RAC? Okay, so meaning that we are projecting it to be this particular direction of RAC. So how we determine that? Because we know vector must always contain two information. The first one should be magnitude. Okay. The second component should be directions. So whenever we have a vector, must always carry two information, which the magnitude and the direction. So how we determine the magnitude here? Simply simple. Okay, what magnitude should be the length of this particular line. Okay, therefore from the diagram, what we can say, the magnitude simply equal to, since we already know the vector, magnitude of RAB earlier, and then by using trigonal, we cos with the angle theta, that will define us the magnitude of projection vector RAB on RAC. Okay. So, and for the directions, we can use the unit vector of RAC. Why we use the unit vector of RAC? Because when we have unit vector, the magnitude always remain equal to 1. Okay, so this magnitude, when we multiply with the magnitude of the original vector, does not change. So by multiplying a magnitude to the unit vector, we are implementing the direction without changing the magnitude of the product. Okay, so that's why we use the direction here to be the direction of unit vector RAC. So the final solution now, so the solution here should be what we're going to have, the vector magnitude RAB cos with the angle theta, and when we're going to multiply the unit vector RAC, which is the vector RAC, and then we're going to divide with the magnitude of RAC. So that's how we determine the projection vector of RAB on RAC. Okay, so meaning that vector can be used in many ways. Okay, we can utilize vector in many situations. So, and then the purpose of vector is just to help us solving engineering problem. That therefore we must always understand the meaning of the symbols and then how to solve it. Okay, and then I'm sure most of you quite familiarized with vector, so this show something sort of revision to all of you. Okay, as a conclusion here, why I'm showing you to in this particular exercise is the way we're going to represent vector in our course. Okay, so as you can see, the vector can be presented in many ways, but for EMT approach, we doing this way. So in my next example, I'm going to adopt the same way to present vector. Hopefully, if this new to most of you, because maybe the way you present vector slightly different. For example, for Cartesian, some of you might use not symbol X, Y, Z, but using I, J, K. Just need to change it slightly to make it, because you need to able to adapt yourself to the new ruling every time you face problem. You cannot maintain whatever you have before. That's what adjusting to the new situation is important. So with that, I'm hoping that you find this discussion relevant, and thank you for your attendance in this particular lecture, and I'm hoping that you can solve the part 3 yourself, because it's not that difficult. So it's quite similar to the product by different definition. So give a try. You got problem, you can just contact me through the email or by WhatsApp. Okay, thank you very much. See you in my next lecture. Assalamualaikum warahmatullahi wabarakatuh.